Hey folks, so this is going to be the third video that we have for section 5.1. So if you will go all the way down, we're going to introduce to you the concept of radian measure. You are pretty comfortable with looking at degrees because we use degrees in our English language, but radians is going to be a little bit different. We don't use that one nearly as frequently, but it's going to be my job this semester to really get your comfort level on radians built up a good bit. We're going to use it a lot, and then once you get to calculus, that's pretty much all they use for the most part. All right, so this particular video is going to be pretty theoretical, so stick with me. If you need to rewind, feel free to do so. All right, so in finding radian measure, I want to point your attention to the graphic that we have here to the right. Notice that we have an angle in standard position where we have our initial side on the positive x-axis. We're rotating. Our terminal side here is this particular ray. And they're pointing your attention to the length of this arc right here. And this particular arc, the way that they've chosen it, happens to be the exact same length as the distance of the radius in this particular example. So let's just take a look at all of these words that we have. I know that that's not your favorite, but we do need them in this particular case. So when two lines or rays cross a circle, and that's what we have right here, the part of the circle between the intersection of the points is called the intercepted arc. And so that's this piece that I was just talking about. It's often denoted by the letter S. A central angle, so that's this guy right here. That is my central angle, is an angle that has the vertex at the center of the circle. All right, so this, it's often called theta. And the way that you spell that Greek letter there, theta, so that you know how to pronounce that. All right, the definition of a radian. What is a radian? Well, we know that we can measure angles in degrees, but we can also measure angles in radians. It's kind of similar to being able to measure distances in miles or in kilometers. It's just simply two different ways of measuring. So here's the definition of a radian. When an angle at the center of the circle, okay, so here's my central angle here. When that angle intercepts an arc, so my angle is cutting off an arc, and that arc is equal to the length of my radius. We've already mentioned that. Then the measure of the central angle, so the measure of this theta, is equal to 1 radian. Now, when we write radians, we do not have a symbol for them like we do with degrees. So the absence of a degree symbol automatically tells me it's a radian measure. So continuing on then with this concept, the radian measure of a central angle theta that is subtended or cut off by an arc of length S on a circle that has the radius of length r is given by theta, here's my angle, is equal to my arc length divided by the radius of the circle. So this is going to be a handy little formula here in just a moment. All right, now let's keep on reading. The number of radians in one whole entire revolution. So in other words, this time, instead of my angle just stopping here with the arc equaling the radius, we want to know what is the radian measure of one whole entire revolution. So let's figure out what that is. Well, in that case, my arc length, remember S is my arc length, my arc length goes around the entire circle. Well, my arc length, when it goes around the entire circle, is also called circumference. And remember from high school geometry, the circumference of a circle is 2 pi r. Now, we're going to take our arc length and we're going to divide by the radius, which is just an r. Well, the nice thing about that is my r's can cancel each other out. And when they cancel each other out, we're just left with 2 pi. If we get the approximation of 2 pi, that's going to be 2 times 3.14159, etc., 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 which is approximately 6.0. 0.28. So then we can say that in one full revolution of a circle, the radian measure of the whole entire circle is going to be 2 pi radians. Now, we know down here, we know that the measure of one full revolution in degrees is 360 degrees. So now we can easily say that if we have 360 degrees, this has to equal 2 pi or 2 pi radians. Not only that, we could take both sides of this equation or this equivalence statement and divide both sides by 2. And when we do that, we're going to get 180 degrees is equal to 1 pi radian. Now let's talk about converting between degrees and radians. In order to convert between degrees and radians, we're either going to multiply by the fraction pi, remember that's in radians, over 180 degrees, or 180 degrees over pi. Now I want you to think with me about why this is legal. What is the value of this fraction? And think back to what I just said right up here. The top and the bottom are equal to each other. And we know that in a fraction, when the top and the bottom are equal to each other, such as 3 over 3 or 12 over 12, when the top and the bottom are equal to each other, then my fraction has a value of 1. So when I go and I multiply something by one of these two fractions, I'm multiplying by the number 1. So I'm not actually changing the value of what I started with. I'm just changing the unit of what I'm using. Okay, so let's take a look on how to convert from degrees to radians. Notice that I'm starting out with 120 degrees, and I want my degrees to go away, and I want my answer to only have radians. So in order to do this, I'm going to opt for the pi over 180. And you say, well, why? Because my degrees, sorry about that. My degrees then will cancel each other out. And it's not letting me, it wants to keep covering itself up. So my degrees are are canceling each other out. So let's go ahead then. I have 120 times pi divided by 180. So I can reduce my two fractions here. And when I reduce my two fractions, I get 2/3 times pi, or 2 pi divided by 3. Doing the same thing then over on part B. When I have negative 300, we want degrees to go away, so we will multiply by pi over 180 degrees. Reduce the 300 and the 180, and you'll get 5 pi over 3, but don't forget there is a negative in front of that. All right, now let's go the other direction. So this time we are wanting to convert from radians to degrees. Now, this one is going to be it's not trickier, but your thinking might be a little bit mistaken. So hang with me on this one. 8 pi over 9 is in radians, and I want my radians to go away. It's not the pi that I want to go away, although it might, but it's the radian that I want to go away. So I'm going to choose the one that has the radian on the bottom so that my radians, even though I'm not writing down radians, my radians are going to cancel each other out. So I'm multiplying by 180 degrees over pi. Now, yes, it ends up that in this particular case, my pi's do cancel each other out. And then I'm just going to probably pull out my calculator and take 8 times 180 and divide by 9. And when I do that, I'm going to get 160 degrees. And notice that my degree is the unit that is left over. All right, now in this next one, this is really going to put to test whether or not you understand that concept of I'm not just canceling pi's, I'm actually canceling radians. Notice I have negative 1.8, and there is no unit. But remember, the lack of a degree tells me it's a radian. So this is negative 1.8 radians. Again, I want my radians to go away. I'm going to choose this one because on this one, the radians are in the denominator. So I'll multiply by 180 degrees over pi. My radians will cancel, even though I can't see them. I can't see that label, but my radians are going to cancel. And now I'm actually just going to pull out my calculator, and I'm going to type in negative 1.8 times 180. I'm not going to put in a degree or anything. And I'm going to divide that by pi. Make sure that you use your pi symbol And your pi symbol is going to be second caret, and the caret button is right up above the division button. So second caret will give you your pi symbol. And so for this one, we will get negative 103.1324 degrees. Remember, we were changing that into degrees, so don't forget your label on that. Again, pay attention to courseware. It will tell you how you want to round your final answer to. All right, we'll wrap that one up for this particular video, and then we'll come back and talk about coterminal angles.